Mic is.
Hello, can everyone hear? Yes. Okay. Hello, my name is Paul Kappler, and I'm with Thomas Ng from Intel Corporation. And Thomas and I have been working closely with the OCP NIC 3.0 community. And today, we're going to talk about something that we get a lot of discussion on in the specification, is how to deal with power in this specification. So we'll go really fast, talking about where we are in the specification, because we want to go fast. Let's go right to our challenge that we want to talk about. In the PCIe chem spec, in aux power, there was only 1 watt available. Now, Ethernet optics, you're already at 1.5 watts per port. There's just no solution from here to there. What we want to kind of talk about is some of the things that we're doing have already been alluded to by other things that that solve this problem, and really put us in a position as an industry to move forward to a place where, depending on the particular system vendor's needs and the NIC's needs, we can have a specification that can morph to the needs of the industry. We got to do this quickly somehow.
Yep. So actually, I think my microphone is on. Can you guys hear me just fine? Okay. So in the concept of the OCP NIC 3.0 spec, it has been alluded before. There's a concept of a power state machine. There's 4 power states in the OCP NIC 3.0 spec. Your first one is the upper left-hand corner. That's NIC and/or AC power off. So either a chassis is physically powered down, or your NIC is physically removed from the system. Once you insert the card into the system, you move into the next mode, is ID mode. Here, your free EPROMs are red, and the baseboard is intelligently querying what the capabilities of the card are. The movement from ID mode in the upper right-hand corner to aux power mode in the bottom right is done via the assertion of aux power enable. Here, you enable RBT, as well as any S5 kind of management in band to your card. Here it is important to note that PCI Express is off, and you are only limited to the aux power budget that we discussed in the next slide. The transition from aux power mode in the lower right-hand corner to the lower left is main power. That is accomplished via the assertion of main power enable, and here you have PCI Express reset deassertion. As previously mentioned in the timing diagrams that others have done, from the specification, that time is 1 second for burst. In main power enable, here you get the full operating envelope of up to 80 watts of power delivery, and depending on your system cooling capability, you may be limited from that. In a quick power delivery example, this is from the spec. Let's go through that diagram. Is this always okay? All right, so, yeah. So this diagram's covered in the spec, but really, ultimately, this covers what I just presented in the previous state machine. In the interest of time, if you guys have questions about this, we'll take it offline.
Let's talk a little bit of this, and then we'll go to the options.
Okay. You want to go for it?
Sure. So within the specification, we give 5 different power delivery envelopes. And this is a kind of an interesting source of challenge and confusion, because we kind of looked at the industry, make some guesses as to where power should be as an envelope, but we weren't sure what the industry is going to do. So the great thing that I think we did, and really thinking for the future and allow the capabilities, is in the free EPROM, we say, what is going to be the power card max power in the main power mode, and what is it going to be in aux power mode? And I'm flashing green. That's nice. So that a NIC card, if you don't quite fit in a power envelope, or you can aggressively fit in a lower power envelope, you can clearly advertise that to the system, and a system can, as the industry evolves, we can optimize and decide, we need a different power envelope, and we can state that, or just immediately as a card becomes available and a system becomes available, we can be reading those numbers from the free EPROM and immediately adjusting to allow innovation in the industry in either conserving power or having to use a little more power as required by the evolution of the industry. So I think this is a really important aspect of the specification. But again, it's not required. Additionally, a system vendor could just say, I don't want to spend all that work in doing the software work to figure that out. We could also operate just like in the old PCIe cards and pre-qualify cards and say a card works when it works and it doesn't when it doesn't. So just because we have this feature doesn't mean you have to implement it. But it does allow for innovation, I think. So I think the kind of the messages that we wanted to show here today is that the power features that we've put in the specification are optional, but they really provide some great capabilities that cards and systems are going to be able to do. You can optionally pre-qualify cards based on the power they actually use, not necessarily based on those tiers that we provide in the specification, but those tiers are intended to provide guidance and a direction to where we can go. You can optionally design to use that aux power mode to help when a card is started and use a BMC. Or if a system vendor wants to do the cheapest, simplest possible implementation, you don't have to do that. You can go right from aux to main power. And finally, hot plug support. On a system, if you can enable having a hot plug controller on your system to deal with a system being hot plugged in, but that adds cost to a system, and it wouldn't be required. So you could forego that and have a system be designed for no hot plug. So kind of went fast today, but thanks everyone for coming and purchasing the specification. Is there anything you want to add?
Just really quick on the hot plug support section, that diagram that let's go back to it. Previous. Okay, so the hot plug circuitry, most of the baseboard vendors we anticipate, if you're going to do a hot plug, it's a cost adder. However, the current specification today outlines the mechanisms that are available to you to support hot plug. In this diagram, we show a hot swap controller for 12 volts in the upper left-hand corner, for example.
So to finish it off, Intel is announcing that we're going to have a product line of OCP NIC 3.0 cards in the marketplace, and we're happy to have you guys come to our Intel booth or the OCP community booth to learn more. So thanks everyone, and thanks Ja for putting us all together. It is our plan to get into the OCP marketplace. Brian's not saying we're there, so we got it. All right. Yes?
I noticed there are combos available during the ID mode.
That's right. The purpose of that is to keep life simple so that the system doesn't have to have the extra circuitry to turn it off, but it's not the purpose that the card would be consuming much of that power, just primarily leakage.
Any other questions?
Good question. Maybe we should write that down in the spec, why we do that. John is saying yes, we should, so I'm hearing it. All right, again, thanks everyone, and thanks for coming today.